All right, so we are solving absolute value equations. Here's our example. Go ahead and write it down. So a good thing to remember when you are solving equations, and they could be in absolute value form, they could be like parabolas, they could be in like completed square form is what we call it, lots of different forms. But what we want to make sure we do when we are solving an equation for x, or in this case k, and you only have the x in one spot, you guys see that? We only have the variable in one spot. If that is the case and you don't have to do the process of distributing to get rid of parentheses, and we don't have to do the process of combining like terms, anytime we have that, we want to do order of operations backwards. So PEMDAS, but backwards. That means your first step is going to be to add or subtract things to the other side. Your second step is going to be to multiply or divide things to the other side to get them away from the variable. Your third step is going to be to do something to get rid of exponents. And your fourth thing, did you hear that? Yeah. Fourth thing is going to be to get inside the parentheses. Okay? And this is the case anytime you are solving for a variable where there is only one variable in the entire problem. Okay? So we're not going to combine any like terms because we only got one variable. So first, is there something that we could add or subtract to the other side to move it away from the k value? Mm-hmm. Yes. What is it? 6. Yeah, the 6 sitting right here, that can be subtracted to the other side. So I'm going to go ahead and subtract that over. So that leaves me with 3, and then we have the absolute value of 9k plus 4 equals 93. And you'll notice when I write my absolute value signs, I usually make them just a little bit longer so I do not mistake them for ones. So just be careful you do not accidentally mistake your absolute value sign for a 1. Okay. Can we multiply or divide something to the other side?
No.
Yes. We got this number in front, right?
Yeah.
So how do you get rid of it?
Multiply.
So it's currently multiplied. How do you undo that? Divide. We're going to divide by 3. That means we divide by 3 over here. So we have 9k plus 4 equals 31. Now here's the trick with absolute value equations. What does the absolute value sign mean?
It's equal.
Always positive, right? Whatever you got here, you forced it to be a positive 31. So either this stuff actually equaled positive 31, and so they said it was 31, or what else could it have equaled? It could have equaled negative 31, and then they forced it to be positive. All right? So now we're going to say always plus minus. There are 2 answers. In all caps. And then if you have a highlighter, you highlight it. Because it's important. We want to remember that. Always 2 answers. Unless it equals 0, because positive 0 and negative 0 are the same number. But if you have a number there that's not 0, definitely going to have 2 answers. So now I'm going to say 9k plus 4 equals positive and negative 31. 2 answers. So 9k plus 4 equals positive 31. That's one equation I have to solve. The other equation I have to solve is 9k plus 4 equals negative 31. 2 equations. So this is the part, right, we had no exponents to get rid of. So this is the part where we were kind of getting inside the parentheses. In this case, they weren't quite parentheses, they were absolute value signs, but either way, these are considered to be grouping symbols. They group something inside, and so now we're breaking inside that group. So what do I do in this equation right here?
Minus 4.
Yeah, subtract 4. So I have 9k equals 27, right? 27. And then what do I do? Divide by 9. And k equals 3. Okay. Over here, what do I do? Same thing. Subtract 4. This time when I subtract 4, what do I get? 35. Okay, and then what do I do? Divide by 9. Does 35 divide into 9? Or does 9 divide into it? No. Can you reduce that fraction? Is there a number that I could divide on the top and also divide on the bottom? No. 35 is divisible by 7 and 5.
Yeah.
And 9 is only divisible by 3. So we can't reduce that fraction. That means that that fraction is the answer. So for absolute value equations, we have 2 answers. Not just 1, 2. Yeah, interesting. That's because of the way the absolute value works. Because so the one version was it could take everything and make it positive, right? It was already positive, so it stayed positive. The second option was everything inside the negative could have been, inside of the absolute value sign could have been negative, and then they forced it to be positive. So we have to do it for both cases. Okay, shall we do another example? Will that be helpful? Yeah? Okay. Hold on. All right, there's our second example. Make sure you got it written down. 7n, yes. So, is there something I could add or subtract to the other side?
Yes.
Yes. What is it?
4.
4. So I'm going to go ahead and subtract it. So I've got 8, and then absolute value 7n minus 8 equals 12 take away 4 is 8. Okay. Is there something I can multiply or divide to the other side? Divide 8. Okay. So now I have 7n minus 8 equals 1. And at this point, what do I say? I separate it, right? I got 2 answers, so I'm going to say I can get rid of these grouping symbols, but once I get rid of them, what do I have to put in front of the 1? Plus minus, I got 2, right? So 7n minus 8 equals positive 1. 7n minus 8 equals negative 1. Got to do it twice. So what do I do over here? Plus 8. So 7n equals 9. And then what do I do?
Divide by 7.
Divide by 7. Oh my gosh, fractions. Ugh.
9 over 7.
Ooh, 9 over 7. That wasn't bad. See how that wasn't bad?
That's bad.
I mean, that's pretty okay. That's pretty okay. What do I do for the other equations? Same thing. Add 8. So that leaves me with 7n equals 7.
N equals 1.
Yeah, n equals 1.
7 does not equal.
All right, 2 answers. There we go. Easy peasy. How could we check to make sure we got it right?
Plug it in.
Just plug it in. Make sure it equals what it's supposed to equal.
Ask